yes, space scientists seeking to understand the enzymatic origins of powerful cosmic rays have detected an extremely rare ultra-high energy particle that they believe traveled to Earth from beyond the Milky Way galaxy. The energy of this subatomic particle, invisible to the naked eye, is equivalent to dropping a brick on your toe from waist high. According to the authors of new research published Thursday in the journal Science, it rivals the single most energetic cosmic ray ever observed, the oh my god particle that was detected in 1991, the study found. Cosmic rays are change particles that travel through space and rain down on Earth constantly. Low energy cosmic rays can emanate from the sun, but extremely high energy ones are exceptional. They are brought to travel to Earth from other galaxies and extragalactic sources. If you hold out your hand, one cosmic ray goes through the palm of your hand every second, but those are really low energy things. Study co-author John Matthews, a research professor at the University of Utah. When you get out to this really high energy cosmic rays, it's more like 1 per square kilometer per century. It's never going through your hand. Despite years of research, the exact origin of these high energy particles still are not clear. They are thought to be related to the most energetic phenomena in the universe, such as those involving black holes, gamma rays, bursts, and active galactic nuclei. But the biggest discovered so far appear to originate from holes or empty space where no violent celestial events have taken place. The recently discovered particle, nicknamed the Amaterasu particle after the sun goddess in Japanese mythology, was spotted by a cosmic ray observatory in Utah's West Desert known as the Telescope Array. The Telescope Array, which started operating in 2008, is made up of 507 ping pong table sized surface detectors covering 700 square kilometers. Yeah, it has observed more than 30 ultra high energy cosmic rays, but none bigger than the Amaterasu particle, which struck the atmosphere above Utah on May 27, 2021, raining secondary particles to the ground where they are picked up by the detectors according to the study. You can look at how many particles hit each other detectors, and that tells you what the energy of the primary cosmic ray was. Matthews wrote. The event triggered 23 of the surface detectors with a calculated energy of about 244 extra electron volts. Then, oh my god, particles detected more than 30 years ago was 320 extra electron volts. For reference, 1 extra electron volts equal 1 billion giga electron volts, and 1 giga electron volt is a 1 billion electron volts. That would make the Amaterasu particles the 244 minimum electron volts. By comparison, the typical energy of an electron in the polar aurora is 40,000 electron volts according to NASA. An ultra high energy cosmic rays carries tens of millions of times more energy than human made particles accelerator, such as the Large Hadron Collider, the most powerful accelerator ever built, explained Galanis, a professor of physics at New York University. What is required is region of very high magnetic fields like a supersized LHC, but natural, and the conditions required are really exceptional. So the sources are very rare and the particles are dispersed into the vast universe. So the chances of the one hitting Earth any 20, said for who was not involved at the study via email. The atmosphere largely protects humans from the harmful effects from the particles through cosmic rays sometimes cause computer glitches. The particles and space radiation more broadly pose a greater risk of astronauts with the potential to cause structural damage to DNA and altering many cellular processes according to NASA. The source of these ultra-high energy particles baffles scientist. Matthews, a co-spokesperson for the Telescope Array collaboration, said that two biggest recorded cosmic rays appear sort of random, with their trajectories are tracked back. There appears to be nothing high energy enough to produce such particles. The Amaterasu particles specifically seem to originate from what's known as the local void, an empty area of space bordering the Milky Way galaxy.